comprehensive explanation of benchmarking in Go and the testing.B type. This mind map provides a detailed overview of benchmarking in Go, particularly focusing on the testing.B type. The explanation below outlines each major branch without technical code. 1. What is benchmarking? Benchmarking is a systematic approach to measure the performance of code to evaluate execution time or resource usage. It helps determine how long a piece of code takes to run and the resources it consumes. Identify bottlenecks. By pinpointing slow or inefficient sections, developers can optimize them to improve performance. Why it matters. Benchmarking ensures that code is efficient, responsive, and scalable. How to. The testing.B type. The testing.B type is a core part of Go's testing package designed for benchmarking. It automates the process of performance measurement. Special type in Go's testing package. It is a dedicated component within Go to facilitate benchmarking. Manages iterations, B.N. B.N controls the number of iterations a test runs. Go dynamically increases this number to stabilize results. Runs benchmarks in a loop. Repeating the benchmark multiple times ensures reliable and consistent averages. It eliminates inaccuracies caused by external factors like CPU or memory fluctuations. How to write a benchmark test. Writing a benchmark test in Go follows a structured approach with key elements. 1. Benchmark function syntax. The benchmark function uses testing.b as an argument and repeatedly runs the code being tested. 2. The b.n loop. Go automatically determines the appropriate number of iterations to produce reliable results. This loop ensures consistent execution. 3. Running benchmarks. Benchmarks are executed using the go test command with the -bench flag, targeting specific benchmark functions. 4. Measuring performance. Performance results are reported in nanoseconds per operation, NSTOP. This value represents the average time taken for one execution of the tested code. 4. Advanced benchmarking features. Go provides advanced tools to measure performance more comprehensively. Allocating memory in benchmarks. Reports memory usage to identify inefficiencies or excess allocations. Parallel benchmarks. Benchmarks can simulate concurrent workloads to test how well code performs under parallel execution. Benchmark-specific functions. Specific benchmarks can be targeted and executed using regular expressions to focus on particular functions or tests. Why it matters. These advanced features allow developers to measure memory impact, handle concurrency, and benchmark selectively, offering deeper performance insights. Best practices for benchmarking. To obtain reliable and consistent benchmarking results, follow these practices. 1. Avoid external dependencies. Minimize operations like file I/O or network requests, which can introduce unpredictable delays and affect results. 2. Minimize garbage collection. Optimize memory usage to reduce the impact of garbage collection on benchmarks. 3. Use table-driven benchmarks. Test multiple scenarios with different inputs to gain comprehensive insights. 4. Repeat benchmarks. Running benchmarks multiple times ensures consistency and helps eliminate anomalies. Why it matters. These practices help isolate code performance and eliminate external noise, making results more accurate. Tier 6. Benefits of benchmarking in Go. Benchmarking in Go is straightforward and effective due to its built-in framework. Accurate performance metrics. Provides precise measurements of execution time and resource usage. Identifies bottlenecks. Helps developers optimize specific parts of the code for better performance. Integrated framework. Benchmarking is built into Go's testing tools, making it easy to incorporate into development workflows. Why it matters. Go's benchmarking tools offer an efficient way to monitor and improve performance without relying on external libraries. Conclusion. Go's benchmarking framework, powered by the testing.B type, is both efficient and reliable. Key takeaways include the ability to automatically adjust iterations using B.N, advanced tools to measure memory, concurrency, and targeted benchmarks. Best practices ensure consistent and accurate results. By leveraging these features, developers can optimize performance, reduce bottlenecks, and ensure their code runs efficiently across various scenarios. This explanation summarizes the mind map comprehensively while emphasizing the importance of benchmarking and its practical use in Go. It is structured to be clear, detailed, and informative.